to joining the online session. So last class we discussed the complex number, isn't it? Complex number. So আমি যখন লিখি তোমরা আমার সাথে লেখার চেষ্টা করো, কেমন?
जी सर।
So it's good for you. And I also try to take a snap or a screenshot when I write whole slides. Okay. Okay, so we said that a complex number has two parts. Okay, for example, z equal to a plus ib. Okay, or 2 plus I3. So this is the real part and this is the imaginary part. Okay, and I is imaginary unit. I is imaginary unit. So I is defined, I equal to minus 1. So this is convention, I equal to root of 1 minus 1. Similarly, you can write I square equal to minus 1, I cube equal to minus I, isn't it? I equal to the 4 equal to 1. So this is the value of cyclic I. And we also discuss about the operations of complex numbers. Operation of complex numbers. Okay, for example, two or more complex number we can add, subtract, multiply, or we can apply division operation as like as real number. Okay, so today I would like to discuss about the complex geometrical presentation of complex number. How can we represent a complex number in graphically? ঠিক আছে? That means today's lecture is geometrical representation on complex number. Okay, geometrical representation of a complex number. Okay, this is important. So how can we represent a complex number geometrically? Okay, so let us consider a complex number, for example, z equal to a plus ib or by x plus iy, as you wish. This A is a real part or real number and IB is a complex part or complex number. We know that this is a com, uh, complex plane. This is a real axis and this is imaginary axis. In geometry, we say that this is x-axis and this one is y-axis. And this plane is called a Cartesian plane in geometry. In two-dimension geometry, we call this is a Cartesian plane. Okay. But in the complex number or complex plane, when we represent a complex number in this type of plane is called a complex plane. Okay, this is called complex plane. Or sometimes we call jet plane. Jet plane means we always represent a complex number as a jet. For this reason, sometimes we call jet plane or complex plane. Okay. So this is the origin we know. The coordinate of origin is 0, 0, and these complex numbers sometimes we can write this or a comma b. Okay, a is a real part. So for example, if we consider m is like this, a is this. Okay, this is a, and if this is a b, because this is the imaginary axis. Remember this. Okay, this is imaginary axis, not y axis. In this regard, we said that this is imaginary axis, and this is real axis. This is real axis because we represent real part of a complex number in this axis. For this reason, this is real axis and this is imaginary axis. Okay, this is a and this is b, so we can write this is, for example, p is a b, so we add this one like as a abscissa ordinate, and this is abscissa and ordinates. If we add this 2 point op, for example like this, if we add this 2 point op, this is root over of a square plus b square. This is root over of a square plus b square. And we denoted this root over a square plus b square by using the r. You know r is equal to what? And this is a theta. Okay. If z equal to a plus ib, r equal to what? R equal to a square plus b square, which is called the modulus. Is called modulus. I think you heard that about the modulus. And this is another one, theta. Theta equal to tan inverse.
B by
This
A.
theta. Okay. This is theta. Theta is tan inverse.
B by A.
Good. B by A. I think you know that. So theta equal to tan inverse B is called
Argument.
good argument. So we should remember this because we need to solve some problem related the modulus and argument. What is the relation between AB and R theta? We know that x equal to or a equal to r cos theta and y b equal to, this is the b since we consider the app coordinate is b. So b is
R sin theta.
good r sin theta. And this is the relation between the Cartesian polar coordinates. If also I can write this one z equal to x plus iy is also good for you to uh, familiar with the x7y in Cartesian coordinate, and r equal to root over x square plus y square and theta equal to tan inverse y by x. So this is the relation between the Cartesian polar coordinates. Cartesian polar coordinates. Okay, x equal to r cos theta, y equal to r sin theta, r equal to this x square plus y square, and theta equal to tan inverse y by x, which represent the relation between the Cartesian and polar coordinates. Okay, I think you all are familiar with these coordinates, Cartesian and polar. We know that Cartesian is related with xy. For this reason, we said that this Cartesian plane is related with xy in two-dimensional geometry, and its polar coordinate are related with
R and
Theta.
theta.
exactly good r and theta. R is in this context, R is called modulus, and theta is called
Argument.
argument. Good. And this is this R and theta are formula to use or to find the modulus and argument. So this is argument. So any complex number, we can find modulus and argument by using the this relation. We can use this relation for finding the modulus and argument. Okay, and this is very important. Another one is I would say you should remember this. This is the diagram. This diagram is called
Argon diagram.
exactly argon diagram. Why this is argon diagram? Because a mathematician Argon introduced this diagram for this reason. This is argon diagram. Okay.
Yes, sir.
Sometimes question in final sometimes comes that what is argon diagram? So a complex number which represent in a plane or in a complex plane, this diagram is called argon diagram. So this is important. Argon diagram. Okay. If you have any problem, please ask question. Then I can stop and discuss your question. Okay, so this is the new things. We know that this is a modulus and this is argument. Okay, and modulus is root over x square plus y square, and argument is tan inverse y by x. So, for example, we can write any complex number. For example, z equal to we can write 3 minus 4i. What is the modulus and argument? Find the modulus and argument. So it's easy, I think, no? Isn't it?
Yes, sir.
Yes. Okay. So modulus is modulus is
Root over 3 square plus
I
minus 4.
equal to 4 square. Sorry, 3 square
Plus 4
plus
square.
minus 4 square. Okay. It's
Yes, sir.
always positive, isn't it? Minus 4 square. Okay. And argument theta equal to tan inverse
Tan inverse minus 4 by 3.
minus 4 by 3. I don't know what is the exact value of this, but you can write by using the calculator.
Yes, sir.
Okay, in a degree or in a radian. So any complex number, we can find modulus and argument. I already discussed yesterday about any complex number which is written by this z1 by z2 this way or rational way. It can be written as x plus iy. I already gave you some homeworks also, one, two, or three, or I don't know. So any complex number, we can write x plus iy, and this x plus iy can be represent modulus is like this way, and argument tan inverse y by x like this. Okay. So any question? Okay, so if there is no question, then I can move forward uh, for our next topics. So, uh, modulus, we can write this modulus, for example, z modulus uh, z is written by absolute value of z or r like this, okay? So absolute value of z equal to root over of x square plus y square, same as r equal to root over x square plus y square, okay? And uh, argument argument of z is written by arc of z, okay? Arc of z or theta. Just we denoted arc means argument. Arc means or theta. You can denote it in this way. So so theta is lies between what? Theta is lies between, for example, 0 to twice pi, isn't it? Theta is lies between 0 to twice pi. But if theta is lies between minus pi to pi, this is minus pi to pi, then this theta is called principal argument. Principal, just rename this minus theta to, this is the minus pi to pi. This argument is called principal argument or principal value, okay? When theta lies between minus pi to pi, then this theta is called principal argument. As usual, we know that theta is argument which lies between 0 to twice pi. See this 0 to twice pi like this, but when this to this just positive way, we can say that this is a principal argument. And we also any complex number, for example, x z equal to x plus iy, we can convert this one is in polar form. Any complex number we can convert in polar form like this, since we know that x equal to r cos theta and y equal to r sin theta. Okay, good. So if you have any question, please
স্যার
ask.
স্যার প্রিন্সিপাল আর্গুমেন্টটাকে মানে মাইনাস পাই থেকে থিটা থেকে ওই মানে ইকুয়াল
Yes,
হবে স্যার এটা
minus pi. This is a minus pi and this is a pi.
স্যার
Okay?
স্যার মাইনাস পাই হইতে পারে না স্যার এটা এটা
না না minus pi হতে পারে।
মাইনাস পাই থেকে বড় হইতে হবে স্যার
Exactly, minus pi
আচ্ছা
থেকে বড় pi থেকে
আচ্ছা ঠিক আছে
ছোট
স্যার
অথবা সমান। This is a called principal argument.
জি স্যার
And we also call argument, but in different way we can say that sometimes principal argument. For example, you are a student of Tripoli, but in a specific way, you are a student of Tripoli in first year, second semester, isn't it? Just a specific way we can say that this is a principal argument. Okay, and I also said that any complex number we can convert Cartesian to polar coordinates or polar to Cartesian coordinates, because we have some relation we discussed in last slides. So in this, now I would like to discuss a question. What region, what region in jet plane is represented by 2 less than z minus 4 minus 5 I less than 3? What region, which region represented in jet plane or complex plane? We know that which one is jet plane, or in, we know that this is a real axis and this is imaginary axis, and this is a jet plane or complex plane. We already know this, isn't it? Okay, so this equation, these equations represent a region, but we have to find what who is the region. তার মানে আমাদের এখানে দুইটা ইকুয়েশন দেখো, this is one equation, this is another equation. These two equations represent a what? Represent a specific region. So we need to find this region. Okay. So at first I would like to say what is the solution. For your convenient, I would like z equal to 2. If modulus z equal to 2, we know that modulus of z equal to what? Root over of?
Root over of x square plus y square.
Exactly, root over of x square plus y square equal to 2. Isn't it?
জি স্যার।
Okay, if you have any question, please ask. This is a simple root over z equal to, sorry, modulus of z equal to root over x square plus y square, since z equal to x plus y. I will. Okay. So we can write x square plus y square equal to 2, 4. What is the 4? 2 square. So what types of equation this? I think
Circular equation,
Circle,
sir.
sir.
exactly. This is a circle equation. I think you all are familiar with this equation. This is a circle equation whose center is 0, 0 and radius is 2.
2. Yes, sir.
Okay,
ইয়েস স্যার।
exactly. So this is a circle which is center is 0, 0 and radius is 2. If I change this one by less than 2, please attention please. If I replace equal less than by instead of equal, then we can write this. Okay, then what is the region?
Sir, all the points that are inside the circle.
Exactly, good. All are points inside the circle, not on the circle. If I use this one less than or equal to, then include it the line also, but in this case only inside the circle, all points inside the circle. It's okay. So we use this concept here. Okay, we use this concept here. In this case we can write given the equation 2 less than z minus 4 minus 5I less than 3. Okay, in this case at first we can write this one z minus 4 minus 5I equal to 3. What is this? I think you know this is the equation of circle. This is equation of circle. And how can we understand this is equation of circle? But we know that this is, for example, if we can write this is equation of circle z equal to 3. Equation of circle, center is 0, 0, radius is 3, isn't it?
Yes, sir.
Exactly. If we change this z by using, for example, z minus 2, for example, then we can write z equal to, you know that x plus iy minus 2 equal to 3. Then we can write z minus 2 plus iy equal to 3. It's okay for you?
जी sir.
Yes, sir.
Okay, good. So this is a modulus. We know that this is modulus. So if we remove the modulus, we can write x minus 2 whole square plus y square equal to 3 square. For example, here we can, this is 3 square, okay? This is also equation of circle. You see, this is
Yes, sir.
equation also
Yes, sir.
circle,
বুঝতে
but
পারছি, স্যার।
center is 2, 0. Center is 2, 0 and radius is 3.
Radius is 3, জি স্যার।
Okay, just same equation. We can convert it this one. So you see, if we can extend to minus 2, then it's also, you see, this 2 is related with x. For this reason, I combine x minus 2, and this is x minus 2 whole square plus y square equal to 3 square. This is the modulus root over. Root over we can remove this modulus by using the square both in both sides. Okay, is you see it's difficult to understand. It's a circle with center 2, 0, but it's easy. In this case, it's easy to say that this is a circle. Center is 2, 0 and radius is 3. Okay, good. If I write, this is example, you know, you can take it as a note in your note kata. So what is that? This is also circle. Okay,
Yes, sir.
this is also circle, but what is the center and radius?
Sir, 4, 5, sir, radius 3.
Exactly, good. Do you understand, everyone? 4 and 5. You see 2 and 0. If you extend here I, then this I related with y, and this is a 2. Okay, so this represents a circle with center 4, 5 and radius 3. Good. It's simple. If you don't understand, then I will take another example like this. This I related with y, and this 4, this is a real part, it's related with x. For this reason, this is a 4 and this is 5. Okay, good. So what is this? If we apply less than 3, you said that this is inside between in the point inside the circle. This is also inside. This is also a region. It represents a region interior the circle. this represents, or this indicate, you can write anything. This represents the region inside the circle. Inside the circle. So we can write here, this is 4, 5. Just I roughly draw this one 4, this one 5, for example. So 4, 5 is here. Just I scale this way. You can scale this, but this is a 4, this is a 5, okay? This is 0, 0. So this is the center and radius is 3. So radius is 3. We can write this way, just roughly draw a circle. Um, Radius is 3. Okay, I have this one. So you can, you see this is a circle whose radius is 3. Just I can put this one. This is a 3. So what is this circle? This is indicate the inside the region. Okay, and this is the equation of this. So we have another equation here again. Again, you can write z minus 4 minus 5i equal to 2. Also represent, we use same language for your convenience. Represent the circle with center, what? With center same, 4, 5, but radius is changed 2. Okay, therefore z minus 4 minus 5i greater than 2. Okay, greater than, this is the less than and this is the greater than. This greater than 2 um, explains or represents
All points are outside the circle.
exactly all points, represents the all points. Good, represent all points. We can write this way also, all points exterior of the circle. Exterior represent a region exterior of the circle. এভাবে লিখতে পারো তোমরা, exterior of the circle. Okay, so you can write this one also like this way. This is a circle, same center. This is called concentric. Okay, concentric means ki same center, but radius is different. You see, radius is different, but center is same. It's called concentric circle. This is this one outside the circle, outside this circle, outside this circle. What our conclusion? So this is a circle. Okay, so what's our conclusion?
স্যার
Therefore,
পয়েন্ট গুলো হলো এই ব্লু সার্কেলের বাইরে রেড সার্কেলের ভিতরে।
exactly, this is called a ring, like as a ring. You know ring, like as a ring, 2 and 3. Therefore, these two equation, 2 less than z minus 4 minus 5i less than 3 illustrate or represents the region lying between the circles. This is answer. But in this case, you should draw this argon diagram. Without argon diagram, it's difficult to justify your answer. So this is answer, okay? Okay, again, we now what is the question you see? Which region represent in jet plane by these two equations? We split these two equations this way, equal to 3 and equal to 2. We know that this represent the circle. Center is 4, 5 and radius is 3. This is also center 4, 5, radius is 2. Okay. And this is the less than means inside the circle and greater than means exterior region of the circle. So these two equations represent combinedly the region lying between the circles. Okay, and we represent this region in argon diagram. Okay, this is very important. You should everyone represent this way. And the scale, roughly, you should just take uh, a scale as a accurate way. Okay, if you draw a circle in this point, it's totally wrong because this is a 4 5, this is not, but this is 0 0. Some student I saw that they draw this circle in this point. Do you understand?
Yes, sir.
So you
Yes,
should
sir.
not draw a circle here.
স্যার পরীক্ষায় কি স্যার সার্কেল ড্র করতে দেয় নাকি স্যার?
Of course, this is a 50% marks or 30 to 50% marks.
স্যার একটা কোশ্চেন ছিল
Yeah,
স্যার এই জেড মাইনাস ফোর মাইনাস ফাইভ আই গ্রেটার দেন টু লেস দেন থ্রি, তাহলে এটা ইকুয়াল কিভাবে লিখতেছি এট ফার্স্টে?
at
ইকুয়াল
first we take assumption, we take this equal for our simplicity, for our understanding, but ultimately we can take this one less than and greater than.
ও আচ্ছা,
Okay,
বুঝতে পারছি। জি
but
স্যার,
it's not a fact. We take is equal to for our simplicity. Okay,
জি স্যার।
not for answer. Ultimately we comments on less than and greater than. Okay, so I would say again, you should take your point roughly here, not here. Okay, I saw several students did this type of mistakes. Okay, any question regarding this problem?
স্যার একটা কোশ্চেন ছিল।
Okay,
জি স্যার, এখানে যদি স্যার লেস দেন ইকুয়াল থাকতো তখন?
exactly. If less than equal to, then it can included the border, but this time is not included the border. This time is not included the border. It's also just like this one inside the 3 and outside the 2. If there is equal, then inside 3 and also the borderline. But in this case, we ignore the borderline because borderline is not in a question.
or equal.
Yes, if you put here equal or equal, this is the depends on its border, but it's not a very big deal. Okay, you just understand what you're doing.
Thank you, sir.
Any another question? Welcome.
সো এখানে কি স্যার ওই রিজিয়নটা শেডেড করে দিতে হবে নাকি জাস্ট তীর চিহ্ন দিয়ে দেখালে হবে?
Shaded, you can did this one finally, but at first you take this one arrow, then you use finally this final region is shaded. Is a good way, but it is not a big deal. This is not a hamper your marks, but you need to draw this argon diagram
স্যার আপনি
because
খাতায়
yes, because we have to represent in jet plane. So if you write only this one and if you do not draw this one, but what is the represent in jet plane? This is called jet plane. We know that this is jet plane or complex plane. And this diagram is called argon diagram. Or sometimes it's called, what is the region in argon diagram? Sometimes call this one like this. What is the
স্যার
region?
খাতাতে আঁকতে হবে নাকি স্যার গ্রাফ পেপার দেওয়া হবে?
এটা খাতাতেই আঁকতে হবে।
রাফলি একবার
এবং রাফলি স্কেলটা ঠিক মতো বসাতে হবে। যেমন দেখো আমি এখানে 4 নিছি, এখানে 3 দিছি এভাবে, যাতে 3টা 4 থেকে বড় না হয়। ওকে, and you should maintain the scale roughly, and you should not draw this circle like this way. Okay, this is totally wrong. Okay, thank you so much. So there are some homeworks for tomorrow, for next class. Number 1, what region?
স্যার আমাদের স্যার এই ম্যাথ গুলোর স্যার একটা স্লাইড দিয়ে দিলে ভালো হয়, মানে কি কি করব এটাই কিছু।
Slide?
জি স্যার,
প্র্যাকটিসের জন্য আর কি।
প্র্যাকটিসের জন্য স্যার।
হোমওয়ার্ক গুলো একটু ভালো করে করো। স্লাইড বলতে কি রকম বোঝাচ্ছ?
স্লাইড বলতে
Example
স্যার
problem
ধরেন
থাকবে।
একসাথে স্যার 30টা
স্যার,
স্যার
বেশ
ধরেন
কিছু
কমপ্লেক্সের
exercise,
অঙ্ক
স্যার।
এরকম, ওগুলো
ও
আমরা
আচ্ছা
প্র্যাকটিস
আচ্ছা,
করলাম
একসাথে
স্যার। ওখান
তো
থেকে
আমি
আপনি
একসাথে
হোমওয়ার্ক
তো
দিলেন।
পড়াচ্ছি না, একসাথে দিলে কেমনে হবে? যেটা যখন পড়ায় তখন সেটা দিচ্ছি, তখন সেটা তোমাদের করা দরকার। আর আমি মাঝে মধ্যে কিন্তু এই হোমওয়ার্ক গুলো দেখবো, এবং
ঠিক আছে।
সেটার উপর ক্লাস পারফরমেন্স তোমাদের ডিপেন্ড করবে। ঠিক আছে? আর তোমাদের তো বই আছে না, বইটা থেকে তোমরা এক্সাম্পল যেগুলো আছে ওইগুলো করতে পারো।
স্যার ফাইন্ডার পরে ওটা কি লিখছেন?
জি, ফাইন্ড দ্য লোকাস। লোকাস মানে সঞ্চার পথ বলে না, বাংলাতে সঞ্চার পথ বলে। ওকে, আজকে এতটুকু থাক।
স্যার লোকাসাইডে কি স্যার জাস্ট ইকুয়েশনটা বের করব?
এক্স্যাক্টলি, জাস্ট এটা দিয়ে আমরা একটা সার্কেল রিপ্রেজেন্ট করি, যেটা সেন্টার হচ্ছে 20 এবং রেডিয়াস হচ্ছে 3। আর এটা তো বুঝতেছো কি করতে হবে। ওকে, গুড। সো আমি তোমাদেরকে এটা ওখানে দিয়ে দেবো। হ্যাঁ, কোথায় যেন গুগল ক্লাসরুমে। ওকে ওকে, রোল নাম্বার 1 আসো,
প্রেজেন্ট স্যার।
একটু তাড়াতাড়ি করবো কেমন? 2 সরি 3
প্রেজেন্ট স্যার।
5 6 6,
Present, sir.
7, 7 aso. 8,
Yes, sir.
9,
Present, sir.
10,
Yes, sir.
11,
Yes, sir.
12,
Present, sir.
30, 17,
Sir, 17, sir. Present.
19, 19, 19 কে?
স্যার আমি স্যার 7 স্যার নেটওয়ার্ক প্রবলেমের কারণে স্যার দিতে পারিনি।
তোমরা একটু পরে বলো যদি কোনো সমস্যা থাকে তাহলে
আচ্ছা স্যার।
পরে বলি। 20, 20, 22,
Yes, sir.
23,
Yes, sir.
24,
Present, sir.
25,
sir.
25, 26,
Yes, sir.
27,
Present, sir.
28, 29,
Present, sir.
28 aso. 31,
30, present, sir. Present.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
4,
Present, sir.
35,
Yes, present, sir.
36,
Present, sir.
স্যার 28 স্যার প্রেজেন্ট স্যার
Present, sir.
করা ছিল তো
38, 38,
স্যার
39,
স্যার 28 স্যার প্রেজেন্ট
39, 40,
Yes, sir.
39 na? 41,
Yes, sir.
42,
Present, sir.
43, 4,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48, 49,
Present, sir.
50,
Yes, sir.
51, 51, 52, 54,
Present, sir.
55,
Present, sir.
56, 56, 57, 58,
Present, sir.
59,
Present, sir.
60,
Present, sir.
61,
Present, sir.
62,
প্রেজেন্ট স্যার
63, 64,
Present, sir.
65.
Yes, sir.
কে যেন মিস করছো বলো?
স্যার 28 স্যার
28 না? আর কে? 7 না?
25 ক্লাসে ছিল, ওর নেট চলে গেছে একটু আগে।
25 না?
জি স্যার, ফোন
আচ্ছা, আর কেউ আছো?
স্যার 172 স্যার।
ও আচ্ছা, সরি। তুমি রিয়াদ না?
জি স্যার।
আচ্ছা, আর কেউ আছো?
7, sir.
7 দিছি। 19, 20 আছো? 5, 19, 20?
Problem, sir.
5, 19, 20 আছো? Okay, good. Thank you again. Thank you all.
19 নাকি স্যার নেট প্রবলেম স্যার
Sir, roll 5 present, sir.
Next week.
Hello.
Allah Hafiz. Assalamu alaikum wa rahmatullah.